Hello and good morning, everyone. Hi, I'm here outside of DC. And welcome, everyone. Thank you so much for joining us today. My name is Lorna Quant, and I'm a faculty at Gallaudet University. I'm one of the co-founders of the CREST network, along with my colleague, Melissa Malskune. The goal of the CREST network is to engage with conversation and collaboration with others in our field who are interested in exploring sign language and technology. And now I'd like to introduce our two hosts for today, Dr. Richard Bowden. He's a professor at the University of Surrey. And he'll be joined by Dr. John Henner, who's a professor at the University of North Carolina, Greensboro. And the two of them are going to be talking about topics related to Dr. Bowden's keynote presentation entitled Computational Approaches to Sign Language Translation. And the goal of this discussion is not to have a formal interaction, but more of a dialogue and a conversation about the ideas presented in the keynote. And we do have some already prepared questions. And at the same time, we welcome questions from the audience. We really want to know what your thoughts are and what you're thinking as it relates to these technologies. So please feel free to use the Q&A chat feature in Zoom, and you can write your questions there. Both presenters will be able to see all of the questions in the Q&A chat, and I'm really looking forward to this conversation. Please also, you feel free to use the regular chat box as well. But we're specifically interested in having you use the Q&A box for questions for the presenters, as it's easier just for both of them to see the questions. Thanks to everyone for coming today. We have such a nice audience from all around the world. It's really great to see names that we know and new names in the participant list. So welcome to you all again. And with that, I think we're going to go ahead and get started with our conversation. Hi, good morning. I think that we might have met maybe in Zurich, Switzerland in 2015, perhaps?
Yeah. Oh yes, most definitely. We spent an evening with me signing BSL, you signing ASL, and some interpreters, which we relied on quite heavily, I seem to remember.
Yes. Well, because the technology for the sign translation wasn't there yet, obviously.
Nearly. Give me a few more years, hopefully.
Yeah, so I watched your video and I thought it was really interesting because I'm tangentially involved in sign language translation for the past 10 years. And I started by advising Thad's group, Thad Starner, his group. So I've been consulting with them on and off for a while, and most recently, last year, I was consulting for Adam Mudner's group. And I think I saw you at a meeting. So our paths have crossed, as well as my interest in this field. So I really enjoyed your presentation, and I've got a lot of questions for you. And I hope you don't mind my asking.
No, no, not at all.
Introducing the Front Gate Outdoor.
So I'll start with the easier questions for you. I'm wondering how much the level of technology has changed how deaf and hearing members have interacting with each other in terms of their own information sharing. So for example, when I was working with Thad's team, there were several of us deaf folks who came, and we thought we were consulting on the best way to translate the ASL. Really what they wanted us to just film us signing some basic things. And I'm wondering how the level of technology has changed the expectations of your deaf collaborators.
Expectations of deaf collaborators. Certainly we no longer invite people in just to capture data from them. I think I mean, I should go back to I was really scared about doing this talk because I think, as I said to Melissa, it's a tough audience as a hearing person, you know, working in deaf sign. It's incredibly important that we are that we're sensitive to the community that we're working with. So I would never invite somebody in just to capture their data. We're there to try and make sure that we get it right, or that they're there now, either in a technical capacity as working with the linguistic teams, or to make sure that we're actually getting it right, and the technology is fit for purpose. How the technology has changed how we interact. I tell you, Zoom has made interaction actually more complex. The meetings, having a meeting in reality with an live interpreter, deaf and hearing, I think in a room is much easier than over Zoom, just because the amount of screen real estate, and making sure that everybody is not talking at the same time. And certainly chairing meetings with interpreters, deaf and hearing, is not something that I particularly enjoy. It's really hard work, really hard work. It's much easier if we can meet in person. But I mean, I think we all know that in some respects, productivity has gone up a bit via Zoom. It's made less travel. I'm not sure whether I answered the question there, but.
What are some of the barriers for entering this field that folks who might be interested in sign technologies would be able to do if they're hearing?
If they're hearing, I don't think it really makes much difference whether they're hearing or deaf. It's the kind of, you need the same skills. You need the technical competency. So, you need the background in computer science and the mathematics, but you also need to know something about sign. So if you're a hearing person, then the first thing I have to do is send people off to go and learn about the problem that they're trying to solve. But this is it. So if you were a deaf person and you want to do work in this area, then you need not necessarily computer science, but it's the kind of the technical background. I mean, coding is a key skill, and pretty much everything we do now is Python. So it's not, it's not quite as elitist programming. Python's a very accessible language, but yeah, Python and good maths are really the key skills. And I think I said at the end of my talk, my dream would be to actually have some deaf members of the research group. So rather than having to send hearing people off to learn how to sign, but I've only really had in all my time one undergraduate who was deaf. So it's a bit. I think that says something. Why have I only ever seen one undergraduate computer scientist that was deaf?
Yeah, I really want to capture that point. Right now, I'm working with many deaf scholars, and there's a really hot discussion about exploitative allyship. And so how do you manage that? Where it happens not just in your field, but in other fields as well. Hearing people will then exploit that knowledge, and deaf community is not given the credit or the reward for that knowledge.
Yeah. I don't know what the solution is to that. I think because it swings, this is it. So you could be criticized for not having a deaf member on the team, a deaf team member. Equally, I've heard people criticized because they've worked with deaf team members, and then works tend to be derivative, so it gets built on things, and then that person that contributed to it doesn't end up on a paper or something further down the line, and then they're criticized that somebody has misappropriated a deaf person's work. I think the rules of publications and ownership for research are irrespective of whether people are hearing or deaf. It's common sense and good practice. So if somebody contributed to a piece of work, then their name should end up on that piece of work. You certainly shouldn't be putting people's names on work just to tick a box. And equally, somebody shouldn't expect that they would be named on a piece of work, several, if it's a derivative piece of work, several layers down. So you might have a deaf team member that's worked on a data set, and they get recognition for that data set, but it's not necessarily right. You should expect that work that then builds on that data set would also, have reference back to the original people that contributed. I think so. I don't really see that it's got anything to do with people being hearing or deaf. It's about good practice internally and making sure that people are recognised for their contributions.
So I'd like to ask, what are you doing to build a pipeline for young deaf students to be able to enter your field?
Well, I have to put my hand on my heart and probably say not enough or nothing, because I don't even know where to start to promote deaf students coming in at the level that they need to, because they need to be doing A-levels, they need to be coming in and doing the degrees and building up. Because the trouble is, I'm recruiting, and maybe this is the it's a cop-out to say, but I'm recruiting for PhD, so they're already graduates at that level. But I mean, I guess I should be doing more to try and encourage deaf to come in at undergraduate level. It's far too easy for me to say, well, that's the job of the university, but I think that's the level. I mean, we need to be encouraging the skills at a much younger age. In the same way that at the moment there's a big push, certainly in the UK, about equality of sexes across. Because if you look at the male-female division in things like computer science and engineering, it's very male dominant, and it's just about trying to make sure that we've got a good balance of people across across all areas, isn't it? So it's not just about whether it's deaf or whether it's male or female. It's just trying to make sure that there isn't a bias that people walk away from it because they don't think it's for them. We should expect to see the same demographics of people across the whole remit, and we don't. So that's what needs sorting. There's some good comments in the chat, incidentally.
Yeah, I know NTID has a summer program, a summer camp for deaf kids to learn about robotics, coding. I know that program exists. I know that there are also local collaborations with different schools for the deaf where they have a robotics team or association. The problem seems to be that the folks who go to the deaf schools for the deaf is really different population. They tend to be from lower socioeconomic status, multiply disabled, they're dealing with racism, racist oppression. And there seems to be more barriers that need to be broken down for them to be able to enter these fields. So here in the United States, we're still figuring out the best way to build a pipeline. And especially now we have deaf kids who just seem to be falling through the cracks. I have 3 kids, they're all codas, they're all hearing, and they experience a lot less of these barriers in terms of networking or getting coding at their schools. And here in my local community, we have a magnet high school that focuses on IT. And there aren't any deaf kids there. And so it really seems that there's a systemic issue. And the goal is to start really forming strong collaborations. And I'm wondering about your experience in the UK. If there are programs like that, where maybe programs that you might be able to support deaf youth.
I think actually trying to find the deaf community in the UK is sometimes tricky. I mean, I'm speaking now as somebody learning to sign, seeking out the deaf clubs, deaf pubs, to try and engage with that community in order to acquire language, in itself is kind of non-trivial. And I used to, in some respects, I mean, I used to go into the deaf pubs in London, and once you've got a circle of friends in there, then okay, it's fine. But actually, I found as a white male very difficult to break into some of these deaf circles of friends, quite rightly, because they're out socializing. Why would they want this hearing person sort of like coming along? So I think actually seeking out the deaf community sometimes can be quite difficult. How do you then engage with them at an academic level? I think the trouble is that, and I have to be really careful because I'm no expert on this, but in the UK, we don't have that many unique opportunities for these communities. They tend to end up in or kind of put away in this kind of little special school somewhere else. So I think, I don't know what the answers are to. I mean, we're talking about some big social issues here that I don't really feel qualified to really sort of comment on.
Mm-hmm. One of the challenges, well, let's say there's a deaf child who has a real connection or an interest in tech. Their peer group might be relatively small. They might not have the necessary opportunity to have a friend who has the same interests and then develop those interests. Oftentimes, deaf kids are just in part of the same peer group because they both happen to be deaf. How do we connect with those students who are interested in tech so they can have a understanding of a whole network of deaf people who have the same interests? And how do you envision your group being able to support that in the UK?
Well, I guess, I mean, what we need is somebody to take an initiative. So something like the CREST network, you know, to have something in the UK that was specifically targeting that younger community to try and bring them together and, you know, promote the opportunities. Now, if that, you know, if somebody came to me and sort of said, right, well, we're doing this, you work in sign, I think you should put your money where your mouth is, I would be more than happy to get involved with that and give those kids some opportunities. You know, we're constantly sort of like being approached by, you know, for summer placements and things like internships for school kids. You know, if somebody approached me with a network like that and said, "Would you do it?" You know, and give these kids from the deaf community an opportunity, I'd be delighted to. But yeah, but I mean, I don't think that really is. That's not something that I could lead on. That's not. And maybe that's yeah. I mean, I'm not an educator of school kids, but I'd be more than happy to give some opportunity. I mean, if somebody approached me now, I mean, and in the UK, I mean, if we do have, when they're doing their A levels, they have to do work placements, and so if there are any deaf kids in the UK who are doing computer science and want a great sort of like summer work placement, then all they've got to do is drop me an email.
It seems that A level is the focus, but we know that deaf kids have systemic challenges with school achievement because of incompetent communications with teachers, peers, language deprivation, oppression in a variety of forms, lowered expectations. And so if deaf kids are not achieving to that A level, and it seems that the population then would not be there for you to recruit from. So what are our obligations then? Seemingly we have to start even earlier to support deaf kids to be able to get to those A levels, then they can then even further achieve and pursue careers in this field. And it's more of, you know, if we're waiting for kids to float up to the top, they won't. If we're waiting for these exceptional kids who might be able to get to the A level, we're going to be waiting a long time.
A lot of the problems that you mentioned there are systemic problems with education, not with coding. You know, that was problems where the education system is failing sort of deaf kids, and that's just education in general, not coding specific.
Well, I think it is related to coding because people are the coders. And there's no detachment from those two things.
Well, I know, but I mean, if the education system is failing somebody, it's normally failing them across the board, not in a specific subject. That's what I meant. No, so it's probably not the fact that it's something isolated to coding. I mean, I'm sure there's lots of schools where they've got a really good teacher who makes coding fun for the kids, you know, and then you've got another school 5 miles away where they didn't really want to teach coding. They were doing something else and they were told they had to because of some government kind of initiative, you know, and the two education experiences that kids are going to get in those two classes are going to be completely different. But, you know, the sorts of problems you were talking about where, you know, I think it's probably going to affect their mathematics and their physics just as much, you know, and their history. It's just their learning in general. And kids are suffering from a poor education system that's not serving them rather than it actually being specific to any one subject. I mean, I think the trouble is, I think it's a lot of hard work. I know. So we have a collaborator at UCL, Neil, and he has an undergraduate degree, and I have huge amounts of respect that he went to, I think, was it Bristol, but he went to. Bristol's got a good reputation, sort of like in terms of its deaf studies and things, but a standard kind of UK university. He was there on his own with what resources that he could like scramble around, in terms of interpreting and assistance for lectures. But he went and got that degree, and that takes real balls, excuse my language, in order to go and do that. To just say, right, well, forget it. I'm just going to do it anyway. And that's what that is what we need. I think you're right that we need to put more in place to help people, but I think you don't get anything in life unless you fight for it, and that doesn't matter what background you're from. There's one thing that my parents told me was, you can do whatever you want to do, but you've got to do it. It's not going to come, so you've got to fight for these things. So, but like I say, I mean, huge respect, but not easy, but it can be done.
One of the reasons I'm pushing this point is because, of course, we're talking about the pipeline, but I really want to make this connection between coding and people. Because your work focuses on language. And what is language if not an aspect of people and people's lives? And so if we don't understand the people and the populations, how can we approach the language?
Well, I'm not sure how to answer that. That was more of a statement than a question, and I don't disagree with your statement.
I think I'm gonna leave that hanging maybe, and we can move on to another part of picking on you. So you've been working on computer vision technology for the past 30 years, if I understand your video correctly?
I guess, yeah, I'm that old.
Yeah. The 90s weren't 5 years ago, unfortunately, right?
Yeah.
Nirvana has actually been, old music now for the past 20 years.
That's true. That's true. I'm still listening to Pearl Jam.
Yeah, Eddie Vedder. I think he's a grandfather now or something.
Yeah.
Anyway, so one of the biggest challenges working with computer vision, as I'm sure you're familiar with, is the camera technology in general. Analog as well as the digital, and as well as it actually has some racist elements to it in terms of white balance. And because of that consequence, we are seeing some issues and biases in computer vision where darker skin cannot be recognized. And I know that there's a big issue in terms of remote monitoring of students during COVID, where dark-skinned students had to have a lot of light on them, or the computer software didn't even think that they were there. And I'm wondering how you, as a computer vision specialist, deal with these issues, specifically with signers who have darker skin, because in your examples, all of them were white-skinned people.
Okay, so you're right that that a lot of computer vision, and we see it in the press a lot, is there's data biases. That's where it really comes from. So the data that models are trained from, there is bias in that data. And so how that manifests itself is that the systems that are trained sort of like have the same biases back as the data, and we see failure cases. So failure cases for minority aspects that weren't in the original data. How do you overcome that? Well, at a fundamental level, you solve the data bias issue, and that data bias is there, everywhere. Whether it's male, we've already talked about male and female, black or white. You can also address it by decoupling the problem. So, and one of the things we were talking about before, I mean, part of the problem we've got, certainly with things like sign language, is a lot of the legacy data for sign language goes back to analog data. A lot of the data that the linguists work with is very old, and by modern standards, very poor quality data. But from a linguistic point of view, it's very rich, and there's lots of annotation there. But that doesn't mean to say that we can't use that and still use more modern data. And just before this call started, we were talking about some of the problems with poor lighting, motion blur, things like that. So a webcam in poor lighting, the exposure time of the CCD increases. We see lots of motion blur for the hands. But we can overcome that. The human eye can integrate over the evidence and disambiguate what it's seeing. And we can do the same in sign. So actually what we've done is we've decoupled the system into lots of interacting components. And one of the things that we're looking at is skeletal estimation, so tracking, and doing that irrespective of things like motion blur. I mean, a lot of the models that are used have a data bias because they're trained on still images from the internet of people doing sports, of people doing handstands. Well, actually, that's a completely different distribution of data to what happens in reality. And so actually what we're trying to do is build models that are specific to sign, because in sign, nobody does a handstand. Somebody is normally frontal to the camera, but actually what we really care about is hand-to-hand interactions, hand-to-face interactions. And a lot of these generic models that are trained on stuff from the web will fail in the context of sign because it doesn't see these interactions. So if we train that model separately, and then we can put that together with another model that was maybe trained on the linguistic data, and overcome the bias that was only trained on white people or males or females, because the front end has been trained on different data where we've been able to get rid of the bias.
So if I'm understanding you correctly, that means that you train your models on different types of people, different complexions. Is that correct?
Yeah. So I mean, I haven't seen any failure cases. So the body model that we're using at the moment, I think, works for anybody. I've not seen it fail on any particular demographic. You're right that as we move over, when we start training on the sign language data, we have to be very careful that actually what we're not doing is destroying some of the generality of the models, and it doesn't become, male specific or female, actually female specific, because quite a lot of the data, there seems to be quite a bias to female interpreters than male interpreters. So the data sets that we do use tend to have a bias towards females.
I know that training on the weather interpretations from Europe was something that you were just doing. And I bet that there's a good portion of white women. I mean, I can't necessarily give you a percentage, but I would say in Europe, that would be the dominant model, as well as hiring interpreters for TV? How does that impact your data?
Oh, well, this is it. Yeah, you're right. I mean, the data has biases in it, and that will pass through to the model. I think we have to be very mindful that those biases are there. And if you wanted to roll that out as a product, this is when the problem isn't with the science, if you know that that's the case. The problem is when, and I'll take an example from that actually happened, was the algorithm's fine, it works in the lab, and when somebody is stupid enough to put that into a product, and that bias then manifests itself as you have a camera that's racist. That's when the real problem is that developing the technology and solving the problems, we can do this with this data, and we know that actually if we want to generalize, then we're going to have to do some retraining. I think that's fine. The problem is when you try and productize it and it's not ready for that market because the biases have been carried over.
So in talking about racist data, I noticed one of your funding sources was for terrorist identification system.
That's a long time ago. And it wasn't, that wasn't to do with appearance, that was to do with identifying internet activity. So it was surfing, the sorts of behavior that is left on a hard drive when you've been surfing the web looking for specific material. So it had nothing to do with the nothing to do with the race of people.
Okay.
You've been digging around,
yeah,
John.
I know that there's some visual data and visual computer vision that's used for that purpose. And I watched your presentation, so that's where I got that. I took notes on what I watched. Sorry, I'm not allowed to. Let's see, where are the QA here? Let's look at the QA. I don't know where to start. Melissa, where would you like me to start with the QA? Hi, can you see me? Hi, everyone. Yes. We've been voting for questions that we like the best. So if you see a question up at the top, that means it's been upvoted with the most votes. So you can just start from the top and skip through them if you'd like, but the ones at the top are the ones that have been upvoted the most. Athena asked about if it's possible to have sign to code. That seems possible using a notation system. Do you think that's possible?
Just reading it. Would it be possible to do within sign language automatic translation? Oh, I see. Right. Okay. Okay. So the question is whether we can translate from sign language to some sort of sign programming language. But the question is, what's the sign programming language? You said something similar to Hamburg, so Hamnesis. The problem with Hamnesis is that it's not really a phonetic representation, and Thomas, who developed it, admits that it was developed to annotate or to describe sign from a linguistic annotation point of view. So you can take the same sign and you can annotate it in two different ways, and that's not ideal that kind of implies it's not really a phonetic representation. The project that I've currently got, Easier, which is an EU project with Thomas, what we're trying to do, there is a concept within that project of something called EMSL, which is European Meta Sign Language. And we're looking at whether we can come up with a better representation that will probably be data driven, that will transfer between languages. And so what we're trying to work, well, what we're working on at the moment is whether we can get the neural networks to basically implicitly build their own phonetic representation. And if we can do that, then that means that we can transfer things between languages. So we could do a whole load of learning on one language where we've got lots of annotation, for instance, DGS, and then take that and move to another language where there's less resources, less linguistic resources, and kind of take the knowledge that we learn in one language and apply it to a less well-resourced language. So possibly, but we still need to work on this phonetic representation, or the sign language programming language.
Another question from Carl. So if we've successfully solved sign language recognition, what happens with that software? Does it become proprietary, or would it be open source?
That's a really good question. At the moment, there are lots of very big companies that are very interested in sign language translation. And I don't know what their plans are, but within the lab, we've been working on this for a long time, and we would rather get there first before some big multinational comes along and swallows up the IP. So for us, I think for everyone who works in the lab, we don't do this to make money. You know, if we wanted to make money, we wouldn't have been academics. There's much better ways of making a living than being an academic. But we do want to solve this problem. You know, so yeah, so I can't say what the big multinationals are going to do, but our intention is to solve the problem. And I'm not saying I'll give it all away free, but I would like to think that any money we make out of it, we would use for good purpose, whether that's to continue the research or solve the next problem, but it would be for the greater good, not to make money.
Okay. We have another question from Athena. I noticed that a lot of your inputs and outputs are 2D videos. And I'm wondering if it would be the same possibility. It would be possible to apply the same technology with using VR and having VR as the data that would feed the model.
Yep, okay. So the reason that we do a lot with 2D video is because that's where the data is, and that's where it's all been. There is now this idea of egocentric sign. So, you know, if you imagine in a VR world, you've got a pair of VR glasses on, and you know you're moving your hand. So really, you're trying to recognize the sign from you know, from the perspective of yourself rather than the perspective of looking at somebody else. There's lots of issues with that. Firstly, it kind of reminds me of Thad Starner's work, you know, and I remember Christian Vogler's talk at our workshop at conference last year, where he was sort of saying that even Thad, you know, sort of said that was a silly idea. I mean, you know, but I think there is I would love to have an AR headset, which is a universal translator, right? So imagine having an AR headset on where I can sign and it would translate that into speech if somebody needed to hear what I was saying. And when somebody's talking at me, I would see a little inset signer sort of like overlaid, providing the translation. You know, so something that is just a simple piece of wearable kit. Now, to do that, then you need to I need to not only be able to see what John is signing and be able to interpret that, but if John's wearing the system, it also needs to be able to interpret. So I think there is a real need for kind of this egocentric system. It's something that we're keen to work on. We're not working on yet, but we do have plans to move there. I think the problem is that the paraphernalia in VR, the VR is actually masking your face, and so that half your non-manuals are gone. So there's lots of kind of logistic issues about, because we know that it's not just about tracking your hands. It's a bit more complicated than that. So.
Mm-hmm. Let's go to another question from Catherine Bentley. In the context of sign to text translation, what kind of computational solutions have you pursued to bridge? And also my curiosity is about dialects, dialect variation in sign language, how computer vision would be able to recognize these various dialects. I know that you mentioned there are people who are accepting or rejecting the matches, but if the person doesn't recognize that dialect, then what?
Okay, so I think dialect, I mean, as speaking as somebody learning sign, dialect's a nightmare, because the dialect differences just in the UK are so drastic that it's almost like another language, but you've just got to cope with them. But they tend to be swaps in lexical items. So it tends to be just a completely different sign for some of the words. A lot of the actual base, grammar's still there. A lot of the base vocabulary is there. What you're looking for is kind of this sign, which used to be this, is swapped for this sign. And that's something that the machine can learn, given sufficient data. But it is a challenge. And this is why historically, we have relied on kind of linguistic annotation, because at least when a linguist annotates data, they are annotating it as lexical items, not kind of, as the words. The problem is that as we move to solving the translation problem, and the way to do that is with vast amounts of data, that these kind of homophones, I guess, sort of like are an added complexity that the system needs to learn. But I think a lot of what we're doing at the moment is about trying to put our knowledge of how sign works into the neural network so that we can do more with less data. So things like dialects and homophones and multiple ways of saying the same thing are all things that we can try and code into the network. Inductive biases.
I'd like to add another question, actually. How do you handle disabled signers? For example, as someone who might have cerebral palsy.
We are not at that level. You mentioned the weather corpus before. The level that we're at for recognition at the moment is very constrained domains of discourse with fairly consistent signing. We're so far away from, we've got to solve the problem first, and then you would look at, okay, so now all of these edge cases, how, so I think that's a long way off. The technology is just not that mature yet.
Looking at the top question about the GAN technology. Can we talk a little bit more about the GAN technology and how that might impact the future of data and translation?
Yeah, well, the GAN is what everyone's getting excited about, because for the first time, it looks like a signer. It doesn't look like a graphical avatar. I haven't read Lucas's question, so I understand that sign language. The second one, which is about the GAN, I'm excited about the GAN. Oh, that was a compliment, I think. Well, yeah, so the GAN is what everybody's getting excited about. The problem with the GAN is really ethics. You know, for the first time, and the video that you saw in the CREST talk is already very out of date. So that was recorded maybe 6 weeks ago. And I've got some, I don't know whether I can show them. I could show. But the technology has moved on leaps and bounds. Ben's been working on it in the lab, and it's looking really good now. Everyone gets very excited about it. The problem that we've had is to do with people's permission, because when we have some data, we haven't necessarily, you know, that data wasn't captured with the view that that person, we would have used the data in this way. And with the GAN, what we can effectively do is, you know, I could take some data of John, and then potentially I could make John say whatever I wanted him to say. Now, that has huge ethical issues. And so a lot of what we're doing at the moment is trying to make sure that the data that we use, we have the correct permissions to use that data. And we're also trying to work on anonymizing that technology so that actually it doesn't look like anybody. The applications are immense. I mean, you know, and I think one of the biggest selling points is anonymity. So as a deaf signer, you know, and sign being your native language, if you want to post something on social media, then, you know, you've got no anonymity at all. But imagine if you could, you know, you can anonymize it so it still looks like a real person signing. It has all the nuances, all the non-manuals that you would expect, but it no longer looks like you. There's a huge application there. But also, I mean, I think where there is an interest in it at the moment is in the broadcast sector, because at the moment for broadcasters, and don't get me wrong, this is not about reducing human interpretation. This is about getting more human interpretation for the money. Because if the interpreter can work from home without the studio, then you're reducing the cost, and that means more sign can be interpreted. But also, if you can give the end user choice over what they want their signer to look like, you know, so you know, if you're a kid, then you can have a kid. You know, it's the classic one to have, you know, and certainly from a kid's perspective, to have the people that you're seeing on TV reflect your demographic, you know, that has huge value. So to give the end user the ability to choose what their interpreter looks like, there's also, you can have a team, potentially have a team of interpreters, but they could all be reskinned to one, you know, to one person. So there's lots of good applications of that tech. Yeah, and it's the one that everyone's getting very excited about. But with all of this generation, I think the ethics, it's not just about the ethics of the appearance, it's also about the IP of the translation. Because if that, you know, somebody owns that translation, there's more than one way to translate a spoken language into sign. And there's also issues with, you can, you know, I do have a video of me animating a GAN, and you can tell it's me. It looks like me. Basically, I put 20 years on the appearance of the GAN because of the facial expressions that I pull. So it's very exciting, but yeah, there's huge things that we still need to overcome in terms of yeah, ethics, and make sure that we get it right. But I think that's probably the closest thing to a usable product that could really the deaf communities could be interacting with. We still need, the actual translation. They're the things that we're still trying to solve, but we're making good progress. I'm not sure I answered the question, but
I actually think we only have 1 minute left. Hi everyone. It's Melissa. Hi, wow, and time is run out, and I see we still have so many questions and comments. I hate to disrupt the flow, but we do have to wrap up. I'm wondering if you were interested in answering any last questions or any final thoughts before we wrap up. I know this is a really fascinating discussion that we've been having for the past hour. Well, I think the last 2 points, I really want to talk about is the pipeline. The pipeline is essential. If you really want more deaf people in this field, we need to have a system where we have a pipeline, and that's really the challenge. And the data is the second issue. The data that's feeding these models. Because the system can become racist, ableist, and oppressive in a variety of ways. So what are our obligations to maintain the data and making sure that we're accounting for these various isms? Richard, any final thoughts before we start our wrap up?
no, I think John makes some good points there. The pipeline is a tricky one, and I think that involves us all as society to sort of like fundamentally kind of address the education system. The data is one of the biggest battles we've got with at the moment. The technology is moving forward so quickly that we constantly find ourselves doing battle with do we have the permission to do this with this data, because it was captured for something slightly different. And going forward, I think this is the fundamental problem with all of the machine learning, is the power is with those that hold the data, not really with those that have the techniques. Because when we publish a paper, if you've got a games machine at home, that you normally play an Unreal game on, you've probably got the hardware to train the same systems that we have. And we tend to release code. So actually, all you really need is the data to do it. And we just need to be a little bit careful who we give our data to. I think we're all getting more and more aware of that.
Yeah, I know that Timette Gibru and Emily Bender recently published a paper about the stochastic in terms of Google, and they're talking about ethics. So this is a prevalent issue in this community, ethics and data. Yes, and I agree with the both of you. This conversation is really just the beginning. We don't have these kind of conversations and dialogues often, where people who are experts in these variety of fields are able to get together in computer vision, sign tech, and discuss these. And I believe that it's not just one lab or even one university that's responsible. It's a huge effort, collaborative and community effort. Funding, how the funding is supporting the new generation, that's another aspect to all of this. Where do we start? Deaf education is the foundation. There's just so many challenges that we're starting to recognize and consider. And my lab, I know we're going to be discussing these issues and this conversation for days to come. And as for the CREST network and the festival upcoming, we've got a lot more presentations coming up in the next couple of weeks. On June 24th, this is a reminder for everyone. We have Raja Kushnalagar and Hufaza the interpreter missed the last name, to talk about visual communication and perspectives for deaf people's rights as it relates to AI. So I'm really looking forward to the conversation on Thursday as well, and being able to carry over what we talked about today into our future conversations. Big data, the deaf community, the sign language community, where everyone stands and all these interconnections. So thank you both again. And for the audience for joining us today. And again, please check out Richard's video, which is available on the CREST Fest website. Watch that keynote again. And he's talking about many technological advances that were incredibly mind-blowing and really exciting at the same time. We have this opportunity now as a community to learn from all of these experts. So thank you so much for participating. Thank you for being